Hey everybody, it's Dr. Schulman. We're going through algebra stuff, so I hope you're as excited as I am. We're going to be doing we're going to be doing formulas, just part B of four, through the working delta. I just finished making all the exams for this course last night, so I think they came out pretty good. I decided to make a practice exam before each regular exam if you want to try them. They're broken down to one each section. You got a numbers operation one, you got an algebra one, you got a geometry one, you got a probability one. So um, they are easier. They go and kind of like they get more challenging as you go. They're definitely easier than the quizzes, but I thought this would make you not be too afraid of the exam. So I'm gonna share my screen, get right into it. But again, this is lots more algebra. So we are doing 4B. So evaluating and symbolically manipulating expressions, equations, and formulas. So all this stuff should be pretty straightforward. I'm gonna open up the notes and then I'm going to get into it. So the first one was really long. I broke it down to three parts. There's just so much different ways you can ask algebraic questions, linear equations. I showed you graphing. I'm pretty sure in the other ones I'm going to show inequalities, how to graph inequalities. There's just a lot of good stuff here. So let me get into the notes. And hopefully this stuff is clear for you. If it's not, just shoot me an email. I am more than happy to help. Oh. So again, this is the algebra stuff. And don't be afraid to show all your students where this stuff comes from. If you can't show them where it comes from, use Desmo, show them graphs, really have them get there. All right, I'll open both at the same time. It's taking a bit. And here are all the questions that I made for you guys. So an assignment, oh, that's the bridge program I made. This is as far as I got, only to 5. So I have to make some more assignments. We're up to 4B though. We'll go to edit, skills. See, it's not nearly as much as before. So get excited. It's gonna be fun. I mean, I hope. I'll show you different ways to teach this stuff as I'm going through them as usual. As soon as it wants to load. But now we're basically graphing, right? That's how we're gonna start. Um, for your students, you're always gonna want to help them get the y alone. That's gonna be their best friend. So here's B. All right, so this is the standard that we're going to do our best to cover. And let me move my weird floating head. So no strategies for evaluating symbolically, manipulating expressions, equations, and formulas. Now, a lot of the stuff we're going to do is going to feel kind of challenging, right? I have tons of stuff for slope. If you want to see some fun stuff, really good ways to help your students. I'll put in some stuff here that I made. Like I showed you ones in the beginning of 4A, I'm always going to try to show you some stuff. And I'll probably add some of these in so you have access to really cool, kind of like lessons, things you can use for your students. So let's get into this. This is just based off of a bridge program that I just recently made. But if you want some stuff, I know like in the videos it's telling you about CUDA software and I've used it for stuff, but this slope one is really good. I'll show you what each of these look like and I'll put them in the thing. So here's one that I made that students seem to like. So it's just a slope review that I made for my Algebra 2 class, but basically they got fun, cute little animals. They're all different slopes. And the good thing about this one, when I made this, I would put in some that were just basic lines, like sorry, my pad isn't being patty. Let's try that again. Here we go. So I made ones like y equals 3, which we know is just a horizontal line. Oops. So y equals 3 is up here. I gave them lines like y equals -2, and I'll show you some stuff that goes with it. So here's -2. And you might think, oh my God, that's on the x-axis. How is that wrong? This is a common mistake students make. But you just have to be like, oh, what is everything about this line? Everything, this is the point -3, -2. This is the point 0, -2. We make a little table, and I always have students make a table no matter what it is. So even though we don't know what this one is, as long as we have a bunch of what's the only thing we know about this is y equals -2. You just let them pick the other points. 1, 2, 3. So ready, 1, -2, 2, -2, 3, -2. So that's how you can make the line. So this equation, even though it's on the x-axis, that's what that line looks like. I did the same thing for the x-axis for this one. But also a good thing about it is that I would give them perpendicular lines and parallel lines, like y equals 3x minus 2 and y equals 3x plus 2. So that way when they graphed it, they would see up 3 over 1 and at -2 up 3 over 1. They would see that these lines are parallel. They're never going to cross, right? And so you can put whatever you want on these, which is really nice. That's why I made that worksheet that way. And then perpendicular lines, -2x minus 3 and y equals 1/2 x plus 2. These are perpendicular lines because the slopes are negative reciprocals. See how this is -2 and this is 1/2. So as long as you change the sign and flip it, one line, -3 down 2 over 1. That's one line. The other line is it's plus 2 and it's up 1 over 2. As you can see, when these two lines cross, they're going to make a right angle. So I like this one a lot. I'll give you this one to use. It's really good for students. I'll actually give you a couple ones in here. So let's go to so you just have some stuff you can play with. But this is a really good resource for you. And I'll obviously share everything that I've made with you guys. If you need more resources, just reach out. So this one's good. So the first one's going to be slope worksheet. Other ones that are on here. This one's fun. Students just kill zombies. I think it's really cute. So you can have them actually put in these equations and see if it's going to kill the zombies by graphing the lines. And this is a completed one, so they could see everything. Which one's killed what. So this one's fun. I just have tons of stuff from like all the trainings I've done. Oh, but that one I probably can't share because it's a pay one. The battleship one is really fun. I'll show you this one just for slopes, and then I'll give you the lesson that goes along with it. So this one they use rulers. They graph the line. Here's the first line: up 2 over 1, up 2 over 1, up 2 over 1. The line missed. So it's kind of like they're playing a game. If they draw the line through it, they'll see if it hits it. Students seem to really enjoy this battleship one. I think I copied it already, but just in case. So I'll put in battleship. Nice. And let's see if we have any other ones that would be worth looking at. Oh, and I wanted to show you this one lesson. So this lesson's really good. So this one, yeah. Okay, so this one's really good. There's tons of other ones, but basically you take the paper, you fold it in half with the graph side up, and the paper just has this, just like that page you saw before, but now I have this XY bar. This one's really good for students because they get to write it in right here, And they get to pick whatever the y's they want, and then they can really understand how to graph a line. And then you got the y equals x, x equals y, or y equals x line. So that way there's not a number given to them, right? It's here they just write a -7, -7, -7. It's gonna be a straight line like this. But this one, there's no number, so they get to pick whatever they want, and they'll see it's this line. Then I got y equals negative, y equals 4, y equals -8, and then y equals negative x, or negative x equals y. And then there's just some good problems, right? There's problems for them to do. Use a point to check. Is there anything else on here? Nope. But these are just really nice to really get students understanding like what graphing looks like and things like that. If you want more, there's tons. I got a Desmos game with marble slides. I got CUDA software, which are always good. The CUDA ones are great. They're just blank ones that students get to work on. They're really good worksheets. Everything is free except for that one that I just showed. So we'll do graphing lesson. So all that stuff is good, you know. Just so you have stuff to work with. Let me try the slope one more time so it looks pretty like the other two. But if you need any resources, don't be afraid to reach out to me. There we go. All right, I'll get into the problems, but I just want to show you that first. Graphing's hard, really hard. Sometimes technology is really helpful so they can like mimic things over and over again. That's why I like this marble slide one so well. And these are just great things if you have your students with your iPads and they've got to figure it out. So you can look at some of these. So basically, we just have to fix this so it hits it. The slope, the intercept looks fine, which is the 3. Because look, if I change this to 5, 4, or 5, now let's look, it's too high. But I have to change the slope, so it shouldn't be, it's too steep. So instead of 4, why don't we make it 1/4? Let's see what happens there. It's not going to hit them, though. See, look, not quite. And it's just really fun for students. Let's make it a slope of, I don't know, 1/2, 0.5. Nice. So that'll work. That'll hit the pieces. Yay. And they get to move this around. There's a bunch of them that they can change. And the best thing about it, oh, so this is like it stops at 4, but we have to keep it going. So maybe we'll make it to 6 or something. I don't know, 7? Let's try 7. Whee! Nice. So I'll give you this one too, but it's just a really great lesson. And the good thing about it is when you go to present mode, after you sign it, oops, sorry. After you assign it, you get to see it from a dashboard. You can translate it on see this languages, and you can make it anonymous, but there's a bunch of challenges here. They have it not just for regular lines, they have it for quadratics, polynomials. There's just a bunch of stuff in here. So feel free to check it out, right? But these are just really good things. I'll call this graph lesson, technology-based lessons, just so you have some stuff. Obviously, work with whatever works the best for you, but all right, that's enough of me blathering on. Time to jump into some problems. Let's see what we got. So I'm in Delta. We're going to graph some lines. Let's make sure we can do this. So the first one, I'll actually draw it out. Y equals mx plus b. There's your m, which is your slope. That's your rise over run. And your b is your intercept. To help students, I always say, we start at the bottom, and now we're here. I guess Drake isn't the real thing anymore, but he used to be cool. So we start at the bottom, and now we're here. That's the -3. That's why we call it the bottom, the intercept. And our slope is up 3. 1, 2, 3 over 4. 1, 2, 3, 4. There she is. There's our beautiful line. Ta-da! Beautiful. Mine looks just like theirs. I like it. All right, let's try another one. If we went up 6 and over 8, we're still on there. If we went down 3 and back 4, we're still on the line. All right, let's go. Let's keep it going. I gotta move this. It's getting in my space for thinking. Get out of here. Can I just move you up? But I'll try one more time. Just trying to grab you, not pause share. There we go. All right, let's go to the next one. Graph a line from an equation. All right, so the intercept is 1. That's where we start. We start at the bottom, now we're here. This is how you can show your students y equals mx plus b. So this is where we start. So we're starting at +1, and our slope is -3/2. That means we go down to 3/2. Start at 1, down 1, 2, 3, over 1, 2. There she is. And there's your beautiful line. Practice these if you struggle with them, but I think they're really good. All right. Now we got to find the slope graphically. Okay, so we have to we just need the slope of the line. I'll give you the whole thing. How do you like that? So y equals mx plus b. Our intercept is 6. And our slope is going to be, okay, our slope is going to be this. Hard for me to see it. So we fall 6 and over 3. So this means 2 to 1. I believe this is it. The slope of the line is -2. Because we go down 2 over 1. Down 2 over 1. Ta-da. So this is the equation. Y equals -2x. Do you put over 1? No, because you always simplify it. What? That's what I got, -2 over 1. Oh, they wanted it right there from the first point. Mine looks the same. You must have one vertical. Oh, okay. Oh, it's because I did it twice. Well, whatever. Let's just do no problem. All right, so this is a positive slope. Remember, to ever read a graph, you tell your students always you read math left to right like a book. Okay. So if we have this, we always read it left to right like a book, and we're going to go up, more money, more stuff. We're rising. So we're gonna rise 1, 2, 3. We need a perfect point. Run 1, 2, 3, 4. So I think they want me to do that, and then they want me to do that. Yeah, that's what they want me to do. I did the diagonal. Draw a line representing the rise 1, 2, 3. I should have read the directions. So 1, 2, 3, 4. So it's 3/4 x. The equation is y equals 3/4 x plus 7.5. But they just want the positive 3/4. We did it. Ta-da. They did it up there. We did ours over there. Now let's keep on going. All right, so sometimes they just give you the points, right? But that's okay. We can use the equation, which is change in y over change in x, which we know is rise over the run. But basically, we can also draw it, right? So we know if it's positive or negative. So we've got 10, -6. So this is 10, -6. And then we have 11, -8. 11, -8 is here. Oh, there's our line. We know it's going down, right? We know it's going down. We're going down 1. Sorry, we're going we're going down 2 over 1. So this is a -2. We can use the points. They want you to use the points. I think I just need more space on this thing. Yeah. All right, let's get into it. So change in y over change in x is your rise over run. So it's y2 minus y1 over x2 minus x1. Your y2 is -8. Your y1 is -6. That's why I know it's going to be a -2 on top. Your y2 is 11. Your x2 is 11. Your x1 is 10. 11 minus 10 is 1. That's why it's -2 slope. I was going to give you the whole equation. If you wanted the whole equation, you would take that and plug it into, we would take either point and plug it into y equals mx plus b. We know that our x is 10 and our y is -6 and our slope is -2. So then we get the v. They just want the -2, but guess what? I'll give you the whole thing. So we have -6 equals -20 plus b. We add 20 to both sides. And the algebra happened. 14 equals b. Y equals -2x plus 14. And if you look at it, it should hit all the way up here for it to continue this line. Yes. Oh, I gotta reload the page. I guess I took too long. Too long. That's totally fine with me. So here it is. Ta-da. I showed you it graphically. I did the equation like they did. You know, either way, you'll get the right answer. And we are up to this one, writing equations of lines. All right, so I showed it a bunch of times. All we have to do is the b is -8, so we know it's going to end in -8. So we just need the slope. So y equals something. We rise one, we run 1, 2, 3, 4, 5. So it's 1/5. So it's 1/5 x minus 8. Ta-da! What? Oh, it's 6. I counted one too many. Well, that's annoying. Let's do a new problem. Sorry about that. All right, so now the slope is -2. So y equals -2. Let me make sure my eyes aren't as bad as they usually are. This is negative. We read left, right. It's going down. So we're going down 1, 2, 3, 4, 5, 6 over 1. So that's -6x. The steeper it is, the bigger it is, right? You saw how the last one was like really wide. That's why it's a fraction. This is up and down, really steep. That's why it's a whole number. That's a really good thing to show your students. Ta-da! All right, let's keep on trucking. Vertical and horizontal lines. So this is where I was really, so these the students mess up the most. So I would always have this on the side. Give them one of these. Just give them a little tape. Y equals -2. X can be 0, X can be 1, X can be 2. You can let them pick whatever points they want, but all we really know is that Y is -2. So that's 0, -2, 1, -2, 2, -2. And there she is. There's our line. So we want a horizontal line. Horizontal. And a good way to think about this, I always tell my students the alphabet will help a lot. So they know X before Y. What comes first, D or R in the alphabet? Domain, range. What comes first in the alphabet? I or O? Input, output. What comes first in the alphabet? H or V? Horizontal. The vertical. And it's the same thing for all of them. These all go left to right. I don't know why that got all weird on me. But sorry about that. But the alphabet will really help them. That's how I know this is going to be a horizontal line. We just have to drop it down to -2. Ta-da! We'll do the other one. I'm sure they'll give me a vertical one next. Oh, now it gets right. It's vertical. And if you want to go the other way, so we know it's going to be an x equals 2, but we can just plot some points. The first point is -1, 1. The next point is -1, 2. Third point is -1, 3. What's always going to be the same? X is -1. Ta-da! I'm going to make you do 2 of them, so you can do 1 of each. I think it'll be helpful to do 2 of these. All right, so let's do it. What is an equation? Okay, so this is where it gets a little harder. As usual, it builds. Math is sequential, it's always building. So we have y equals mx plus b. We have the point, we have the slope of 1/2. We just need the intercept. So you see how we have the point this 4, -6, right? 4, -6. There's your x, there's your y. So 1/2 times 4 plus who knows equals -6. Well, you can make this a fraction by putting it over 1. -4 over -2. So either way, or you can just cross them. I usually just cross them and put a 2 here. So 6 equals -2 plus b. Add 2 to both sides. And we're left with -4. And that gives us the whole equation. Sorry, my pen isn't the best. I guess I gotta change the ink on it. I got a couple more. All right, so y equals 1/2. Wait, my sign's off. I looked here, I saw it said 1/2. I looked here, and I thought my equal sign made that negative. So 1/2 is just a +2. So we have to subtract 2 from both sides, which makes this a -8. I almost messed that up. So 1/2 x minus 8. Sorry about the mistake right there. Good thing I caught it. Ta-da! Ooh, and they showed it to us too. I like it. I liked it a lot. All right, let's keep on trucking. I thought we just did it. Didn't we just do it? All right, whatever. I'll do one more of these. All right, whatever makes sense. So here we go. Y equals mx plus b. We put in what we have. That's your x, that's your y. -5 equals -3/5 times 5 plus b. This is over 1, they cancel. -5 equals -3 plus b. Add the 3. And we have -2 equals b. Here's our equation. Y equals -3 over 5 x minus 2. We did it! Exciting times. There she is. All right, well, we had to do it twice. It happens. All right. So this is where it gets a little harder. So this is like a combination of all the problems that we've already done. So we first have to find this. They don't give us slope, so we got to find the slope. So remember, it's change in y over change in x. So y2 minus y1 is really just going to be -2 minus 1. And your change in x is going to be a -6 minus a -4. -2 minus 1, that's -3. These get added together over -2. A negative divided by a negative is 3/2 or 1.5, whatever you prefer. We pick any point. I'm picking the first one. I'm going to do it again. Y equals mx plus b. My y is 1 equals -4 over times 3/2 plus b. That's all I need. Right? This is -4 over 1. I'm going to cancel that. So it becomes a -2. Or you can do 12 divided by 2. But either way, we're going to get 1 equals -6 plus b. Add the 6 to both sides. And we're left with b equals 7. So there's your equation. We have our slope. We have our intercept. Y equals 3/2 x plus 7. Ta-da! Got our slope, plugged it in, got the intercept, and there's a pretty graph for us. Always add context for students, so they know why they're doing what they're doing. All right, so we just did this. These are doubled. You don't have to do double, so I'm taking out these diagonal only ones. Just so you don't have to do the same problem 4 times in a row. That's too much. So let's keep going. Find the x and y intercepts. Okay, so we have our graph. There's your x, there's your y. X-intercept, how much is y? So for your x-intercept, this means y is equal to 0. For your y-intercept, if it crosses this line, for your y-intercept, that means your x is equal to 0. So that's all we have to do. x minus 10y equals 8. So if I make the first one 0, so this is for my y-intercept because my x is 0, I just get negative 10y equals 8. Divide by negative 10. So my y-intercept, we always have to write like a point. So my x is 0. What is my y? 8 over 10, that is negative 4/5. So my y-intercept is negative 4 over 5 when we divide it by 2. I would like it as a point. I always write it as a point, but the way they have it doesn't seem like a point, right? I'll do it the right way. All right, now our x-intercept means my y has to be 0. So x minus 0, negative 10, x minus 10 times 0 equals 8. You just cover it up. So x equals, sorry, that's equals 8. So just x equals 8. So this is going to be 8, comma, 0. Don't be afraid to put it on a graph too. Oh, I gotta reload the page. That's okay. 8, comma, 0. The other one was 0, comma, negative 4/5, right? Yeah, negative 4/5. And there's our answer. There she is. So they don't want it as a pair. See, I already don't like it. It should be a pair because we are talking about a point here. The fact that they don't want it as a point kind of annoys me because we're talking about points here. But guess what? What can you do? They told you how they wanted it. I gave them the answer. Ta-da! Graphically, algebraically. So you can just type these into Desmos and have your students check with it. So our equation is x minus 10y equals 8. There it is. There's the one intercept. There's the other intercept. If you do 4 divided by 5, you get 8/10 or 0.8. All right, let's keep on going. We're in 4B. And we're here. Graphing this from intercepts. All right, so drag the red and blue dots along the x-axis and y-axis. Okay, so we have a line here, but we have to do the intercept. So if this is 0, this is what they want us to do. These are good problems. So here's the first one. I'll do one intercept first. 2x minus 5y equals 20. If this is 0, it's 2x. Anything times 0 is 0 equals 20. We are basically just dividing this by 2. So our x-intercept is 10, 0. So this has to be a 10, 0. Now let's do the y. 2x minus 5y equals 20. This is 0. So this just goes away. Divide by negative 5. Y equals negative 4. Here's negative 4. We did it. I just want to make it perfect so it doesn't yell at me. Ta-da! Wow, they did a lot more steps than me, but that's okay. All right, I like matching. Let's get our match on. All right, so this is not in simplest form, which is kind of annoying. So they want to do the intercept. So our y-intercept is 0. It's 5, sorry, 5. So that just means that this has to be 5 and this has to be 5. They're both 5. which is kind of crazy. So we know we need two fives, but are they positive or negative? Hmm, this looks like, hmm, I think they're both positive. That's a positive five, that's a positive five. That's what we're gonna go with. We're gonna go with this one. You know why I know that? Because if I subtract this, this is why I know it's true. Well, one, they're both fives, so we can just divide it by it. We can plug in zeros, right? We can do all this fancy stuff, right? But this is what I just did in my head. So I did this. I minused 5x to both sides. I got 5y equals negative 5x plus 25. Okay, that was my first step. And we're dividing this by 5. So we're left with y equals, do you see how this is not negative 5? We're just dividing by 5. So you see how this is going to be a negative 1x, or just a negative x plus 5. The slope is negative. That's why I knew this 5x had to be positive here. Down 1 over 1, down 1 over 1. But that's what I did in my head. We got it. We got it. Ooh. Oh, and then they work out all the other ones that are incorrect. Wild. That's fun. We didn't have to work them out. We just used our brain, but you can work them all out if you want. All right, now parallel and perpendicular lines. All right, so find the slope of a line perpendicular. You're gonna have to do two of the, oh no, because we have a bunch of them. I was gonna say you have to do two, you don't have to do two. So to do this, you first make it y equals mx plus b. If it's parallel, you can show your students that parallel has the symbol in it. So that's the symbol for parallel. It tells you what to do. Equal slope. I don't have a fancy one for perpendicular. It's just the one that's not parallel. That's the symbol for perpendicular. And the slopes have to be negative reciprocals. So if our slope is 4, the other slope is 4. If our slope is 4, the other slope is negative 1/4. That's basically all you need for these. Equal slope, negative reciprocal slope. So we have this equation, x equals negative 4y, sorry, x minus 4y equals 16. We're going to add x to both sides. I'm going to put the x before the 16, so it looks like our equation that we want. So we're left with negative 4y equals minus x. That x is positive. And 16 minus x isn't 15. That's a mistake a lot of students will make. So negative x plus 16. We divide both by negative 4. So we know our equation is y equals what's negative divided by negative is positive. So it's 1/4 x minus 4. Now, if we want parallel, we want the same slope, but we can't have the same minus 4. If we have minus 4 again, the lines look like this. Negative 4 up 1 over 4. If I make it negative 4, both lines are over each other. They're not parallel. So I just need to put y equals 1/4 x plus 2. You pick anything else you want. If it was perpendicular, it would be negative 4. So here we go. Y equals 1/4 x plus 2. We did it. I mean, I hope we did it. Sorry, it keeps making me load the page. My internet's, I guess, being spotty today. What? Please do not write an equal sign. Oh, they just want the slope. Well, that's annoying. 1/4. That's why they didn't do it. Okay. Except for this one. If it had the whole piece, it would be the same line, not a separate one. I don't love the question, but what can I do? I'm only one human, right? All right, let's keep going with these parallel perpendiculars. All right, cool. So what is the equation of a line that passes through this that's perpendicular? Okay, so this one requires 3 steps. First step, we minus the 2x. We always want to have it look like y equals mx plus b because it helps us a lot. Negative 3y. This is not 7, okay? It's negative 2x plus 9. We divide by negative 3. Remember that both of them get divided by negative 3. Draw yourself a pretty lotus flower. And we're left with y equals 2 negatives make a what? Positive 2/3 x minus 3. So there's our equation. We want it perpendicular, right? So perpendicular means we want the slope to be a negative flip. So y equals negative 3/2 x. Oops, sorry. Negative 3/2 x minus 3, right? But we want it passing through this point. We want it to pass through this point. So this means my x is negative 2 and my y is negative 2. So it's negative 2 equals negative 3/2 times negative 2 plus b. This is the only piece we need to change. I make this a fraction. They cancel. Keep the negative sign. So this is negative 2 equals 3 plus b minus the 3 to both sides. And we're left with b equals negative 5. And we're good to go. So here's our full equation. Y equals, the negative reciprocal is negative. I can barely talk. Negative 3/2 x minus 5. We did it. We did it. We did it. Ta-da. And there's the pretty graphical picture of it. I did not do it that way, but that's okay. I think I did it this way, but you can also do it graphically. All right. We are up to multiple choice. All right, find an equation of a line that's parallel to this and through this point. So it's basically the same problem, but now it's parallel. 4x minus 4y equals 8. We minus the 4x from both sides. These cancel. I have negative 4y equals not 4, negative 4x plus 8. We divide by negative 4. These cancel. Y equals lotus flower. Negative over negative is positive, which is x minus 2. All right, so we have ours, right? So it's just has a plain one, right? But we have to see if it goes through this point, -1, -9. So we know that the slope has to be a positive x, but it can't be -2. Well, we can try it, right? We can try it. This is going to be -9 equals -1 minus. Nope, that does not work. This one, it has to be. We know the slope has to be positive x. And that's a negative x, so this doesn't work either. So we have to plug these both in and see which one is our friend. So -4, positive 32. And if I move that over to the other side, I think it works. Let's do this one. This is -4, -36. And this one also works. So both of these work, right? If I plug in these two numbers, the x and the y both work. However, we want a what? A positive x. The only way I'm going to get a positive x is this one, because this is minus and that's minus, and two minuses make a plus. This is just minus. That was a lot of thinking, but we got the right answer. So here it is. We have it. We have the slope. And then they want us to plug them all in. Ta-da! Oh, wow, fancy. Incorrect, 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 correct. And then you can see the additional steps to get it correct. What a tough problem. Oh, let's keep trying. So we've done this one before. We might as well try it again, right? So we've got a proportion. So we have piano, minutes. So I just like doing minutes and weeks. Minutes over weeks. So we got our girl Paisley. She does 630 minutes for 5 weeks. What happens in 4 weeks? And there's our X. I'm just going to cross multiply. I have 5x equals 630 times 4. 25, 20. We divide this by 5. We're going to get 504. That's what I believe the answer is. We did it. Oh, we could have done it with the constant. I showed you the constant a lot before, but there it is yet again. All right, let's try this one. Zin needed to get her computer fixed. She took it to the repair store. The technician at the worked for 4.25, 71 for parts. What was the total cost of labor? 219.75 equals $71 per parts plus 425x. We just minus the 71 of both sides. And whatever we get, we're going to divide it by 425. Two calculators, one is just fine. So we have 219.75 minus the 71 for parts. Then we're dividing it by 4.25. You want to see me divide decimals again, you can, but either way, it's $35 per hour. Nice. We did it algebraically because it's an algebra section. All right, equations and context. Got our girl Savannah. She buys cheese and oranges. 38.86 is total. So we need one that has a total. Okay, so it can't be A right away. We know it's B, C, or D. 691 for the cheese and 5 bags of oranges that cost the same amount. I like this one. 5 bags of oranges that cost the same amount. Wait, no, I don't like this. Which equation or tape diagram could you use to represent the concept if B represents how much each bag of oranges cost? I believe it's 5B plus 691. I'm going with D. I'm going D. Let's see what we get. Nice. This was tough. Didn't really make sense. I wanted to do this, but that wasn't a choice, right? I didn't have this one here, so I just had to look algebraically. And we could actually figure out each bag of oranges, 639, the same exact amount that the other one costs. Nice. Toughy. They're getting harder. All right, let's write and solve some equations in context. Members of a softball team raised $15.50 to go to a tournament. They rented a bus and budget 21 per player. Write and solve an equation. Okay, so they raised 1515.50 equals whatever they rented the bus for, 1032.50 plus whatever it is, and 21 times per player for meals. Yeah, there we go. There's the equation. So this is what we got. We got 1515.50 equals 1032.50 plus 21p. We're going to subtract that. We're going to subtract that. Then whatever we get, we're going to divide it by the 21. That's all we're doing. I feel like we did enough of these in the other one for me not to go in super depth. But those are the steps. Minus 1032. So there's your subtraction. We're dividing 43 by 21. And you bring 23 players on the trip. Ta-da! I did the algebraic way. There's your picture. All right. These happen all the time. We did these before. I put some of these on your test and quiz and stuff because they're tough. The sum of three consecutive integers is 54. So x is the first, x plus 1 is the second, x plus 2 is the third. Sum means we add them all up. X plus 1 plus x plus 2 equals 54. I have how many x's? 1, 2, 3. So that's 3x. I have plus 3 equals 54. We minus 3. We minus 3. We get 51. And we divide 3 on both sides. And I believe that is 17. I believe it's 17. I don't know which one they want, but the littlest one is 17. So these are our three choices. Our smallest one is 17. Our next one is 18, and our next one is 19. They said find the value of the least. So the babiest one is 17. And there we go. What? Oh, it said even. I just read consecutive. Oh, so even would be three numbers, which is 16, 18, and 20, instead of 17, 18, and 19. We're doing a new problem. Let's do another one that one's too easy. Okay. Do they have another one with evens and odds? What? This one's weird because it's 0. I'll do this one. If it was even, it'd be x, x plus 2 and x plus 4. But whatever, let's try this one. Oh, here it is even. Okay, so here we go. So let x equal the first, x plus 2 is the second, and x plus 4 is the third. Because 0, 2, 4, 6, 8, but their sum is 0, so I believe they have to be negative. X plus 2 plus x plus 4 is 0. Wild. All right. There's 3x plus 6 equals 0. They got a minus 6 to both sides. So 3x equals negative 6. Divide by 3, divide by 3. And this is x equals negative 2. All right, so the first one's got to be negative 2. Negative 2 plus 2 is 0, and the third one's positive 2. Negative 2 and 2. Yeah, there we go. Those are the three. They want to find the least of the three. Negative 2. Makes sense. Theirs looks just like mine. Beautiful. Way to get tougher. Oh, that was just level 1? Woo! All right. Evelyn is older than May May. Their ages are consecutive odd integers. Okay, so even or odd, we're still adding 2. If the sum of Evelyn's age is 2 times May age, what? All right, so you always put what you don't know, okay, as x. So whatever we don't know about, they say the sum of Evelyn's age and 2 times May age is 7. Oh, it's not like that. It is tough. So x is, I'm going to go with May with Evelyn. And Evelyn is older than May. Oh, so Evelyn has to be x plus 2 because she's older. And May it's got to be x. Find their age if the sum, so we're adding them together. The sum of Find Evelyn's age. If the sum of Evelyn's age, Evelyn is x plus 2, and 2 times May's age. So this is 2 times, oh, hers is just x, is 71. How tricky was that? So 2x's and 1x, that's 3x plus 2 equal. The hardest part is setting them up, right? You can watch that video I did. So we're going to minus 2 to both sides. 69 equals 3x. Imagine somebody saying that. I'm just double your age plus 2. Divided by 3. So how old is this girl? She is 23. So we got our girl May, who's 23. Evelyn is 25. And yeah, that makes sense. That makes sense. So what do we got? Find Evelyn's age. Evelyn is the 25. Not May. How tricky was that? These are the steps. My steps look the same. Beautiful. Ooh, oh God. Don't do method 2, where you subtract from the other way. That's hard. All right, let's keep going. Now let's do some inequalities. A rental car company charges $68.25 per day and 0.07 per every mile. Once we rent a car knowing that she plans to drive 100 miles, she has the most $280 to spend. Because we can only be at 280 at the highest, and she plans to drive 100 miles. So the charge is $68.25 a day. And she plans to drive 100 miles. So 68 times D times, well, it's 100 times 0.07. So how much money is that? $7. There's the equation. D is less than or equal to, oh, we got to do the whole thing. So it's $7 for the miles. She's going 100 miles. So that's 273. And the only time this inequality is going to flip is if we have to multiply or divide. If this was a negative here, we had a negative here, we multiply or divide by negative, that's the only time that's going to flip. So we just divide this by 68.25. We'll know exactly how many days. So let's see what you got. 273 divided by 68.25. How many days can you do it? She got 4 days, at most 4 days. Ta-da! We did it this way, cost of miles, we subtracted it, divided. Actually, ours was this. We did this algebra way. What was this way? Unwinding. Yeah, one at a time, which is fine. All right, let's keep it going. A rental car company charges $68.43 per day and for every mile. Tayshawn wants to rent a car knowing that he plans to drive 250 miles and has at most 340. So the 340's got to be on this side, and it's got to be bigger than that. So our only choices are C is out. So it's just A, B, and D because that's at most we have to spend. And it's 68.43. We want to be less than that. So oh, these are both the wrong way. So it got to be B or C. And this one has days in the wrong place. So 0.05 times 250 has got to be the $12.50. Take your time with these. What? That's what I have. Per day. Oh, because it's that, not the miles. All right, let's just do another one. Sorry about that. Anna has a points card for a movie theater. She received 25 points just for signing up. So that's 25 plus 25 plus So it's got to be one of these. 8.5 for every visit to the theater, and she needs at least, so it's one of these two, but she needs at least so she can get more. At least this means, what is the minimum number? Okay, they want the minimum number, so it's this one. I believe it is this way. Oh, it's the other way? I was right with the at least. Okay. Sorry, I keep messing these up. Let's do another one that was hard like that. Here we go. So at least it's the other way, and the other one's for at most. A rental car company charges $48.27 a day every mile driven. Tyree wants to rent a car, knowing that he plans to drive 325 miles in maximum number of days. So we just need to do 0.08 times 325. So we know it's got to be plus 26, right? Whatever we want is plus 26. And we can't go over the 410. So it's got to be between these two. The maximum numbers he can spend while staying within budget. So I guess I keep messing these up. So we can't go over this. This 410 has to be greater than whatever we do. Otherwise, we won't be able to afford the car. So you really have to think it through over which way the inequality goes. Nice, 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 nice. So we're going to write and solve one in context. Noah needs to order some new supplies for the restaurant where he works. The restaurant needs at least 507 knives. All right, so 507. We need at least this many, so we could have what? More than that. Sorry, at least this many. We could have more than that. There are currently 353 knives, so we already have 353 plus whatever else we need. If each is 10 knives, oh, 10x. Each are 10 each. So we need at least this many. So 507 is less than or equal to the amount of knives we have, plus 10 times each set, and then we solve. So to solve this, 507 is less than or equal to 353 plus 10x. We're going to minus 353 minus 353. That's 4. That's 5. So that's 154 is less than or equal to 10x. We divide by 10. Our answer is going to be 15.4. All right, so the number of knife sets can buy to have enough knives. Well, this is 15.4. So I always do this. I always have to round up in our case because we want one more set, but usually can't buy a half a set, just like there's not half a person. So usually with most of these questions, I usually round up just so we know. Oh, they just want the inequality answer? It would make more sense for this one if it was the whole knife set, right? If it was 16 knife sets we can buy, but I'm not going to argue with the computer. This doesn't make sense based on the situation. The answer should be 16 or more sets. So even though this is correct, the real answer would be, because nobody in a store is going to sell you 15.4 sets of knives. Number of solutions in a system. These happen all the time, right? So one solution means they crisscross. That's one solution. No solutions means they have the same slope they're never going to touch. And infinite solutions means they're on the same line. So when you have this, you can graph them both, right? I would suggest graphing them both, but we can just add them together using elimination. We add these together, 0, 0 equals 0. Does 0 equals 0 every time? So this is the same line on top of itself. And I can show you that's the same line. Here's the first one. X plus y, it's the same exact line, equals -9. There's the first line. The next line is going to fall right on top. Negative x minus y equals 9. Ta-da! They fall right on top of each other. Infinite solutions. Do a couple of these. Get the hang of it. It'll be good. All right. If 7x minus 6y equals -9 is true, what would be the value if we multiply this by -3? So this is like dilating. If I multiply these two by -3, I have to do it to the other side. So a -3 times a -9 is a positive 27. Just means if you do something to one side of the equation, you have to do it to the other. That's all this means. You do it to one side of the equation, you have to do it to the other. We got the same value. All right, here we go. This one you're going to see. This one's on every one of those stupid exams. They give you the lines. Where do they meet? 7, 0. Remember, X before Y like the alphabet. It's so nice when they give you the lines. So we're good to go. What? Oh, it's 0, 7? Oh, God, X before Y. I just said it. I got all overconfident. +3, -7. Can't believe I had a moment like that. But guess what? We all make mistakes. X before Y. X before Y, just like the alphabet. And here we go. -2, -4. Can't believe I had a moment, but guess what? We are all human. We all make mistakes. All right, let's do one of these guys. All right, so the first one is -6. And our slope is down 1 over 2. That's our first line. Our second one is -3, up 1 over 1. And there's where they meet, -2, -5. Have fun with these. Practice with them. They'll definitely help you to understand that you know exactly how to graph anything. Let's try a level 2. Y is level 2. You got to solve this for Y. But the first one we don't. So ready? -3. Down 1, 2, 3 over 1, or we go the other way. Ready? Up 1, 2, 3, back 1. See, that's the same line. And here's the other one. X minus 2y equals -8. I'm going to subtract x. Remember, this is not a -9x. It's just -2y equals -x minus 8. Divide both by -2. Those cancel. Y equals, lotus flower it, because it goes to both. This is like a -1. So -1 over -2, that's 1/2 x plus 4. So we got to go to +4, up 1, over 2, over 2. There's your answer, -2, 3. Oh, I got to put the parentheses around it. Sorry. Sorry, computer. Ta-da! Cool. All right. Now, I gave you some of these. They always come up with, you do the same thing as if it was numbers. So I always tell my students, just pretend it's numbers. So we have J equals -H plus D. So what if it was 6 equals -4 plus D? Because we're solving for D. The first thing we have to do is add 4 to both sides. And that's it. So D equals J plus H, or 6 plus 4. So it's just J plus H. You treat them like numbers, then you just do the same thing. Let's get harder. I'm sure it goes up. Oh, there's only. All right, so we want to solve for B. 4H equals B over 4 plus G. I would treat these all like numbers, but I'll just show you the way that I do it. I would just do, ready? Boom, boom. I made the butterfly. So B times 1 is B, and this is 4H times 4 plus G. So there's 2 ways you can write this answer. You can write it as 16H plus 4gh, or you can write as 4h times 4 plus g. I don't know. We can do the long one. It doesn't matter which one we do. Either answer is going to be correct. See, they want it like this, but we gave it like this, same answer. All right, let's do it multi-step. All right, now we have to solve for b. G over b equals m over q. I really like doing these if they were, I always try to show you how I would teach it. So I would just go and look for physics equations, formula sheet. This is how I would always teach it, just so you know. I would just take a regular physics formula sheet, doesn't matter what it is, and look how many there are, right? So these are real ones, instead of them just making it up. You could take any one of these, and just be like, oh, solve for R, right? Oh, solve for I. If I equals mr squared, right? And then you could actually have them look up what they are so they can learn more. Doesn't matter what they are. I've done this one, these. As long as you just pick one letter, they can solve for them. So I equals mr squared. We're solving for R, so the first we have to do is divide by m. R squared equals I over m. The opposite of a squared is a square root. So R equals the square root of IM. I think that's really useful. So for students, you want to give them a good way to learn literal equations. Just print them out, one of these, and you could even have them be like, for every one of these equations, pick a new letter. Done. You saw how fast I found that formula sheet. All right, let's do the one they want. They want solve for B. There's the first move. We got BM equals GQ. Divide by M, we're done. See, the physics ones would have been way better. So it's just GQ divided by M. Maybe they'll give us a harder one. I doubt it though. Nope, not that hard. Oh wait, it is, because we have a B here. Okay, so here we go. I was hoping for a toughie, they gave me one. So F squared B equals QB. So you see how there's a B in both? The first step you have to do is move the B over. We just want the B's alone. So 5n equals, I'm basically subtracting F squared B to both sides. So that cancels. So I have QB minus F squared B. Now, the B's aren't alone, but they're at least on one side. So this is where you have to do something called factoring. It's the opposite of distributing. We have to pull out a B of both because we can divide them both by B. So I have B equals Q minus F squared. And then because that's times, we just divide it by the Q minus F squared. That's your answer. Wasn't that fun? So your final answer is going to be Fn divided by Q minus F raised to the second power. We did it! Ta-da! That one was tough. I'm glad they gave you a heart. All right, there's a couple left. Transforming the formula. Oh, they did give you a physics one. I guess we think the same, me and Desmos. The formula to calculate gravitational force between two objects, where m1 and m2 are masses, and g is the gravitational constant, and r is the distance between objects. Solve for r. So we basically just have to solve for r for this crazy thing. It's basically what we just did before. I don't know why they give you all these extra little bits, but it doesn't matter to me. G, m1, m2 over r squared. The problem is this in the bottom. Well, to get it in the top, we just have to cross multiply. So GM, I just basically did that. And then this is being multiplied. The squared is last because that's the thing that's closest to it, divided by FG. And finally, to get rid of a squared, we square root. So that's your full answer. So your answer is square root. Um, okay, G, M1 times M2. And this whole thing is going to be divided by the force gravity. Nice. Or the exact same way. All right, so now we have a system of equations. All right. We did this one before, but that's okay. Determine three ways to have as many apples as bananas. Three ways to have three times as many apples as bananas. So that's one apple, that's three bananas. Cool. So the numbers of apples are 1, 3. There's a million ways to do this, but I actually really like this as a lesson. All right, so now we need two apples and so now it's 2 and 6. This will really help students understand it. And here's three apples, and we need 9 nanners. Each of these is 3 times as many bananas than apples. All right, now I get to plot them. So we have 1, 3, 2, 6, and 3, 9. So 1, 3, 2, 6, 7, 3, 9. Cool. There's our first one. Now we have to make $5. Wait, how much do they cost each? One each. So I'm going to do one of these. And bananas are 50 cents. Oof. We might as well do 4 apples and 2 bananas. That made $5. All right, we gotta make $5. So let's go 3 apples and 4. 3 apples and 4 bananas. And finally, I guess I can do 2 apples and 6 nanners. That also made $5, so 2, 6. You only need 2 points to make a line. So the first one I'll do is 2, 6. So here's, oh wait, which one's which? All right, so 2, 6 is, oh no, can I clear it? All right, cool. You just click on top of it, it goes away. 2, 6. Oh, well, there's our answer. Oh, but I can't use it. But we know what the answer is. So we can only use 3, 4, and 4, 2. So here's 3, 4. 3, 1, 2, 3, 4. And the other one we can use is 4, 2. 4. I know it's not correct. 3, 4. I know. I just clicked on the wrong little box. Oh, so it's 2, 6. I think this is fun. Way more fun than just doing it all the other ways systematically or elimination way. But yeah, we got it. All right, let's make these harder. Oh, because I didn't before. Okay. We got Bubakar. What a cool name. Bubakar made a note of all the bicycles and cars he sees parked and or locked. All the cars are exactly 4 wheels, and all the bicycles have 2 wheels. How many vehicles were on the block if there were 8 bicycles and 14 cars? All right, so the total vehicles, if they're all the cars had exactly 4 wheels. Do they want to know the total vehicles or the total wheels? The total vehicles is just 8 plus 14, which is 22. And then this is just all right. So bicycles, I'm gonna go 8x plus 14y. I'll figure it out however they want. Oh, just x plus y. I get what they were trying to do. Okay, so Natalie has 2 summer jobs during the week and she works in the grocery store. The weekend she works in the nursery. She gets $16 an hour, then works in the nursery, and $17 per hour to work at the grocery is 60 and the other one's 17. How many total hours does she work? She does 15 at the grocery and 8 at the nursery. How many total hours? So the total hours she works is just G plus M. And I thought they would want to know how much money, but they just want the total hours, which is 15 plus 8 because they're doing it in 2 steps. It's 23 hours. I was trying to actually solve the whole thing. All right, here we go. Publisher needs to send many books to a local realtor. And we got small and large boxes. The small box can hold 20 books. So we'll do X is small. We'll do Y is large. A total of 12 boxes were set. So that's X plus Y. So I always do amount and then value, or you could do money. So ours is amount and books. So X plus Y, that's going to be our 20 books. Sorry, 12 boxes. Then we know that one is the small is 20. So that's 20X plus 45Y equals the 340. So we'll do X is the number of small boxes. Y is the number of large boxes. X plus Y equals 12. I'm sure there's a million ways to do it, but this is how I did it. 20X plus 45Y equals 340. And then you solve it. I would solve this elimination or substitution or graphing. We might as well do it all 3 ways. So here's the elimination way. So this is X equals 12 minus Y. So I can just drop this into here. So this is 20 times 12 minus Y plus 45Y equals 340. Then we would just solve it. That's one way to do it. So that's 240 minus 20Y plus 45Y equals 340. This pen is going to drive me nuts. 20. Then we've got 12 minus Y plus 45 equals 340. This is one way to do it. There's a million ways to do the problem, though. Oh, it's because it's the very end of something really long. That's why. It's not even the pen. All right, so we have 240 minus 20Y plus 45Y equals 340. So we got a minus 240, so this is 100. And negative 20 and 45 is 25Y. Divide by 25, Y is equal to 4. So if Y is 4, that makes X 8. That's one way. The other way would be you multiply this by 20 and you subtract the 2. You're still going to get that answer. And the fourth way is this. X plus Y equals 12. The other is 20X plus 45Y equals 340. And there it is. What? Oh, 45Y, not 34Y. I was like, that's not the right answer. There we go. 8 and 4. What did we get? 4Y, 8 for the other one. They didn't ask you for everything. I gave you it all. Ta-da! But if you actually want to know the values, it'd be 8 small and then 4 big. They used S and L for small and large. Use whatever you like. All right. Summer camp is organizing a hike. And let's do graphing this time, since we just did it the other way. Actually, let's do elimination. We haven't done elimination yet, so let's eliminate. The granola bars come in small and large boxes. Okay, so I'm going to do X is small. Y is large. The camp bought 3 times as many small boxes, and which altogether had 88 bars in it. Okay, so they gave us the amount. So they didn't give us the other one. So this is 8X plus 12 y equals 88. That's the first equation. And then they just said that they bought 3 times as many large as small. 3 times as many large as small. That is 3y equals x. Now, I can't really eliminate because I don't know the other side, but I can basically just take this and drop it in. So it's 8 times 3y plus 12y equals 88. So that's 24y plus 12y equals 88. That's 36y equals 88. I don't know, there could be something wrong here. 3 times as many large boxes. Yeah, it's the other way around. So if I want 3 times as many of this to make it equal, it has to be like this. So 3 times as many large boxes. So if I want to set them equal to each other, I believe this has to be 3 times it, because if this is 6, x would be 2. Yeah, that makes sense. So we still have to replace it, but now it gets replaced here. So that's 8x plus 36x equals 88. So that is 44x equals 88. X is equal to 11. 44 divided by 88 is 22. So we have 22 of these, 22 small, and 66 large. I made that simple mistake. I said 3 times more, but it would work the other way with the algebraic equation. Really think about that, because that's like the real issue it is. So there's 22 here, 66, 22 plus 66 is 88. 66 is 3 times as much as 22. That's why it's got to be opposite. Whoa. Did I make a mistake? 88 divided by 44. It's just 2. Oh my God. I'm so stupid. I don't know why I put 22. So it's 2 and 6. So I messed up twice on this one. All right, let's do it again. Samantha's a songwriter and collects royalties. She's earning 30. It's played in a commercial, and 80 every time it's played in the movies. So 30x plus 80y equals 620. That's the first equation. 30 for commercials, 80 for movies, 620. She earned on 14. Oh, it's just commercials and movies. So this is just x plus y equals 14. We don't know which one's which. So here we can do elimination. I was going to do substitution again, but I want to show you elimination. So if I multiply this whole thing by 30. All right, so our first line stays the same, 30x plus 80y equals 620. And we're going to do negative 30 to each of them. So negative 30x minus 30y. And if you don't know it's 480, you can use this. Oh, 420. Good thing I used it. Negative 420. And we just add them together. When we add them, these cancel. So we have 50y equals 0, 0, 200. Divide by 50. These cancel, and you get 40. That's 40 for what? I'm just checking myself, maybe because I've done too many. My head's spinning. 200 divided by 50. Again, my zeros. Oh man, I'm just having a moment today. The reason why I knew it couldn't be four, and I should have just stopped right there, is because guess what? It has to equal to 14. Ah, so we got four movies, and that means we have 10 commercials. There we go. 10 commercials and four movies. Ta-da! Good thing you checked. That's why you always should look, make sure it makes sense. See the stupid mistake you're making. I don't know why division's just not being my friend in this moment, but that's why you have calculators, right? All right, here's the last two. We got to solve graphically. Samir owns a food truck that sells tacos and burritos. He sells tacos for $5 and burritos for $7.50. Samir made a total of 450 revenue. Sold 15 more tacos than burritos. Tacos are X, burritos are Y. The first one's just going to be 5x plus 750y equals 450. There's your first equation. We're going to minus 5x to both sides. We have 7.5y equals negative 5x plus 450. We're dividing them by 7.5 divided by 7.5. Y equals, I'm using the calculator. Considering I made too many mistakes. So the first one is 2/3 and negative 2/3 x. The other one is 60. So there's the profit. So we're starting at 60. We're going to go down to over 1, 2, 3. So instead of 2/3, I'm going to do negative 4, 6 maybe. They go by 5 each. Okay, so because they go by 5 each, I'm going to do negative 10 over 15. So we're going to go down 10, 1, 2 over 5, 10, 15. That's how I can use the graph. Down 10 over 15. So there's the profit margin. What's the other equation? Sold 450 in revenue, 5 and 750 each, and he sold 15 more tacos than burritos. So let's not make that same mistake we did. So 15 more tacos than burritos. So if it says 15 more, always just have your students use an equation. So let's say if I sold 10 burritos, how many tacos did I sell? If there's 15 more tacos than burritos, if this is 10, this one's got to be what? What's 10 plus 15? 25 tacos. That's going to give you this, all right? So if it is 10 burritos, right? So that's 10y equals 25x. Now we just want y alone, so we have to divide this by 10, divide this by 10. So the other equation is just going to be 0, 0. And we just have to go ready up 25 over 10. And we're going with what do we got? I can barely see it. What are we talking? 18 tacos and 46 burritos. I want the exact number, so I'm just going to use Desmos. Let's see how we did. 5x plus 7.5y equals 450. Wow, it's exactly the same as the other one. That is wild. Oh, we just can't see it on the graph. I was about to say. And one is 15 more than the other, right? So we know it's y equals 15 plus x. Oh, because it has to start. Well, we got 27 and 42. It looks like we have not that. All right. So the first one is we can't, this would be negative. So our first point is off. So let's get rid of that guy. Let's get rid of this guy. Oh, okay. The first one's got to be what? Our first point has to be 0, 15. That was my mistake. And our second point means we have to go up 0, 15. And for every 5, we got to go 15 more. 5, 10, 15. I think that's it. They look weird. So we've got, I don't know. Let's just look at it and see where I messed up. We know it should be 27, 42. 0, 15 sounds like the start. What was the other one we had? We had y equals 25 over 10 x. This is what I thought it was, but that's not a whole number. So we might as well go with the green. 27, 42. Let's see. X equals, oh, I think it's because I was using X and Y instead of them. 45 and 30. Yeah. All right, let's do another one. Tough. All right, let's figure this out. Not using Desmos. We got our boy Christopher. He's a songwriter who collects royalties on his songs. Christopher will get $40 on a commercial. So we'll do, what is commercial? X is commercials. Y is, I guess, movies, right? His total earnings on all commercials and movies were 900. Okay, so 50 for commercials plus 150 for movies. That's 50x plus 150y equals what? 900. First step I'm going to do, I'm going to make my life a little bit easier, considering I'm tired and I already missed some. So ready? Boom, boom, boom. All right, so I'm going to do 15y equals negative 5x plus 90. Divide by 15, divide by 15. Y equals negative 1/3 x plus 15, 30, 45 plus 4. So we're starting at 4. And we're going to go down 1 over 1, 2, 3. Let's see what the key is on the bottom. Yeah, sweet. Down 1, 1, 2, 3. So there it is. So there's the first one. All right, and now Christopher songs were played on 3 times as many commercials. 3 times as many commercials than the number of movies. So 3 times as many commercials as the number of movies. That would be 3x equals y. Does that make sense? Because if it's on 2 movies times 3, 6, yeah, 3x. So it's just y equals 3x. Okay, that means we can start at 0, 0. And we're going to go up 1, 2, 3 over 1. That doesn't seem right. Go. I have it backwards again. 3x, 1y. It should be rise of a run, but this is, so it's this 3y equals x. I don't know why, but it's the only one that makes sense. So we're saying we got 6 commercials and 2 movies. Let's see if this is right. It's the only one that logically makes sense. Y equals negative 1/3 x. It's 6. Gotta be kidding me. You gotta be kidding me. I did it all right and I divided wrong. Oh, that's so frustrating. All right, one last one. Might as well. We all make mistakes, right? So we got Benjamin, 2 jobs, $12, washing cars, 6 for walking dogs. Cars is X. Cars is X. Dogs is Y. All right, so $12 per washing cars. 12x plus 6y equals 120. I can't believe I got so much of the division wrong. Let your calculator be your friend, okay? I think it's also due to me writing on this. Negative 2x plus 20. And I'm gonna do it. I don't care. All right, not gonna argue with it. So the first one is 20, and we're going down 2/1. Cool. All right, what's the other one? Last week he worked 2 more hours walking dogs. 2 more hours walking dogs than hours washing cars. Does that make sense? 2 more hours walking dogs than washing cars. More hours walking dogs. So that means if I walked 4 dogs, more hours walking dogs than washing cars. 2 more hours walking dogs than washing cars. So this is so this would be x plus 2 equals y. I think that's it. So we're going with, he worked 6 hours washing cars, 8 hours walking dogs. Now let's make sure that makes sense. 2 more hours walking dogs than washing cars. Yeah, we did it. Yay. I don't know why that sentence kept messing me up. That's why it's so hard. The hardest thing is converting them into sentences. So don't be afraid if you mess up too. Took me some time. All right, Deepa decided between 2 parking garages. A charges $8 plus 5. B charges 11 plus 4. In times T. Okay, so A is $8 plus 5T. B is $11 plus 4T. Oh, do we want to know? Write an equation in terms of T would make the same. And we're talking hours. At how many hours are they the same? So we just have to figure out when they're equal. So y equals 8 plus 5x. Y equals 11 plus 4x. We'll use substitution here because they're both the same. So 8 plus 5x equals 11 plus 4x. We're going to minus the 8, which is 3. We're going to minus the 4x, which is equal to 1x. So it's 3 hours. Don't be afraid to do this one graphically as well. If you want, you could always do it graphically. That's just your choice, you know? We'll see that it's 3 hours. And then the other one's going to be the price. 8 plus 5x. See how I don't need the y? 11 plus 4x. Should make the same at number 3. Move my floating head, and it's going to cost $23. Ta-da! They didn't tell you the price, but the price is right there. All right, one last one to go. And then you would have seen tons of algebra. Let's see this one. A small town of 2 local high schools currently has 600 students. All right, has 2 local high schools. A has 600 students, projected to grow by 100 per year. All right, so one is going to be 600 plus 100x. And the other one's going to be 800 by 50x. And I'm assuming we got to know when one has more than the other. So the first one starts at 600, and it goes up by 10 per year. So that would take it 10 years to go 100 more. Oh, it's by 100 per year? Never mind. We're going up 100 per year. My 0 disappeared. So there's your first school. The other one's starting at 800. This one goes 50 a year. So this means it would take us 2 years to go up every one. 2 years to go up every one. So they are the same 4 years down the line. School A currently has 600. Okay, so school A will have more when it's more than 4 years. It'll have more after 4 years. Oh, fancy. I like theirs. All right. Well, that was all of them. Took a while. I hope you learned a lot, but guess what? We're done with all of algebra, the first half. That was a lot of algebra. I hope it was useful. I hope it was helpful. And feel free to just reach out if you have any questions or if you ever want me to give you more teaching skills or tips or anything, and have a great day.